app. So first, what I'll do is I will run the application, and then show you all the features of the applications. After that, then I will go through the code and talk about the code a little bit. I will try to keep it brief. So the first thing I've done is I've gone to the main class and I've pressed played, which allows me to run the application. First thing you can see that there's a feature called full sign which is off, and that's because all of that signifies that there are some spaces left in the car park. So and you can also see that the payment option, which is not currently present, but that'll be coming soon in the next phase. So first what I'm going to do is I'm going to see that there's I guess 4 options, 4 essentially cancels, but you have different options for different parking type. I will go with the electric vehicle number 3, and you can see that there's currently 33 spaces available for for electric vehicle parking. Because I'm a non-member, I'll go option 2, and you can see that for option 2 that I need to present my reg number. So I'll just do C24 UVA. So now after I've entered my reg number, this has allowed the barrier to be raised, allowed the car to be entered, and after that the barrier has lowered, and it's also given me the time when the car has entered the car park, and it's also given me extra information regarding payment. Again, this is more for future features, and now it has asked me how I want to park my car. So that uses different strategies. I've used different. I've used a strategy pattern to allow a different types of parking strategy. So one is closest to the gate for entrance, I suppose, and for early entrance or exit, that's closest to the gate, or 2, which is the next available parking spot. I will pick 1. You can see that the distance from entrance is 1.5, but if I want to say so that I've because I've occupied that space now, the status has changed to occupied. Or if I can, I suppose I can do 2 to change the parking space, and then park the space again, and so I'll find because I chose 1, I'll select 2 to have a different strategy of parking car. So now I'm a bit further, but this was the next car park available spot that I've spotted, and then I suppose I'll do 1 to leave the car park. You can see now that after I have left the parking spot, that status is free as compared to before where it was occupied. So I've left the car park, and it also it tells you when I've left the car park, and it also informs that in future the ticket will be issued automatically based on when you've come in and when you've exited the car park. And we're back to the main menu again. So I'll stop my car park console application. I'll just quickly talk about the code itself. I'll start by the core features, which is of course the car park, and again with the car park itself, I've used generics to assign car park as a type of T, which extends vehicle. I thought this would be pretty useful in terms of allowing it to extend for future users. Say if the car park allows not just cars but also allows different types of vehicles. So just for that extensibility and scalability, I've used generics here. And again, car park what it does is it houses different other classes. So you can see it has got parking spots, sensors, barriers, and ID reader, and all of that is housed within the car park. The method itself, it's all getters and setters essentially. But I suppose what you need to understand is all of these features are essentially a component of car park. And I think the classes themselves, they're pretty self-explanatory as to what they do. The sensor allows the car to be detected. Barrier allows the car to enter or leave the car park. And we've got ID reader. So I'll quickly talk about ID reader now, which is an abstract class, but that extends into a plate number reader, which is for non-members, as well as barcode reader, which is for members of the car park. ID reader itself is an abstract class, but they've been extended into barcode reader and plate number reader. Again, this is to distinguish between different types of members who will enter and use the car park. So that's how I use my abstract class. And I think for the core features, that's it really. I've also used a parking spot, which is another important feature within the car park. And I've used different enum types to assign different types of car park. So moving on to so the core features are pretty self-explanatory really. Most of them have getters and setters. So then we move on to more of the management class, which is what's that happening? Which is the car park manager. Essentially, so what car park manager does is all of the so this essentially handles the business logic within the application. It's almost like a service class, I suppose. But what the car park manager does is it gets the car park, then it also gets other classes that go with car park. For instance, I've got car park registry, and which also extends to member registry, which so the registry classes, what they enable is they allow the cars that have come into the car park to be stored into the database, and once they leave the car park, they'll be removed from that registry. Parking spot strategy again. So this is where I've used a strategy pattern, which allows the user, which allows the user to use car park using different strategy, and of course I've got the car park, and the methods inside of what they essentially do is. They enable car parks to be managed. How I suppose how they enter or how they exit the car park, and what happens when they enter the car park. For instance, they'll be added to a registry or they'll be removed from the registry. All of that business logic is essentially within the car park manager. I'll quickly talk about the parking strategy that I've used, which starts as an interface, and that has been implemented into different types of strategy. So parking spot strategy, what it does is there's different methods here, which is finding the spot. Of course, you need to find the spot to park the car. That was the logic behind that. And you park the car and then you leave the spot. First, we'll talk about ordered parking strategy, and I've used tree set for this strategy because of the efficient search time complexity and removing time complexity. I believe it's off one complexity, and I've decided to use tree set because it allows because it's not just a set, but because it is an implementation of a sorted set, which I thought would be useful in terms of, for instance, comparing with the spot ID, and this is how the cars would be parked in terms of the parking spot ID. In terms of the next parking spot ID, which is also available, you can see that here, and that's what find spot does, is that it finds the first parking spot that is free, essentially, and parker is of course what it does is I've used iterator to go through the tree set, and it removes from the tree set, and it also sets the status of the parking spot to occupied. And leave spot is, of course, it removes it doesn't actually remove it. What it does is it removes the spot from the parking spot, and then it sets the parking spot status to free, and then it adds the spot back again so that it can be used by someone else. In terms of the nearest parking spot strategy, I've used priority queue because it is I want to say it's an implementation of a mean heap, or what is it? It's example of a mean heap. Because what I wanted to do is I wanted to compare the distance from the gate, and I wanted to order it by the smallest distance, such that if you wanted to park closest to the parking spot, you would essentially pick the mean heap, pick the top spot of the mean heap, essentially, and that's what that does here. Again, find spot. You're finding the free spot that is essentially at the top of the mean heap. Carpark again, same scenario as order parking. You're parking the car, you're setting the status to occupied, and you're also returning that parking spot. And leave spot again, you're removing the spot, you're removing yourself from the spot, and you're setting the status to free so that it can be used again. So I've used priority queue for nearest parking spot strategy, and tree set for ordered parking spot strategy. Just interesting way of doing parking, I suppose. Then we'll move on to the presentation layer of the application, which is the car park menu. Again, I think there's not much to talk about the car park view, which is just a bunch of print that I've used for a car park menu. The car park menu itself handles the flow of the application, which takes in Park Manager. Again, Park Manager handles the business logic of the application, and I've used the Park Manager here to show you how it starts. So you start with you start with starting the application. Then you choose the space, and then depending on different types of member you are, you can handle that. Again, enter the car park and leave the car park. Leave the car park space, leave the car park. I've also used for the database layer itself, I've used a JSON file which I've imported for the park loader, just to allow I suppose to show an already filled car park, essentially, rather than having everything from start. And I also want to talk about the builder pattern. I've used so two types of builder, for one for carpark manager, because it had it had loads of different attributes, so I thought it would be easy to create a builder pattern and set it up. Then I've also done for carpark manager, which essentially pulls the data from the database, and then it builds a pre-made car park. So the car park directory essentially is used to build a car park, for instance, that's already been pre-built, and I've also made a builder for building car park with manager, which uses the car park builder manager. And there's also different tests that I've done. It's all JUnit test mostly, I suppose. But yeah, that's my application. Thank you.